In this session, I am going to explain the advantages, disadvantages of linked list and types of linked list. And I also explain how it is created linked list. Here in this session, you can able to learn what are your learning representation of linked list, advantages and disadvantages of linked list and types of linked list. Representation. Here you can see how it is represented. Before that, I have explained what is node. Node is nothing but one is data item, or there are two parts in the node. First part is where the item is inserted, that is called as data part, and next part is the where it stores the address of the next node. That means here if you think this is a node 1, node 2 and node 3, in the next it is consist of the address of node 1. Linked list can be visualized as chain of the nodes where every node points to the next node, and this is the first node which is called as head, and second, third and fourth node, and the last node is always the having the null value because it is used to identify how the linked list is where the linked list is ended. See, by diagrammatically you can see it is looking like our train. That means this is head, that is engine, and these nodes are called as what? Coaches. And yeah, at last the last coach is having backside there will be a red light. That red light is nothing but our null value. That red light indicates that the end of the last coach, and here also it indicates null value. This is the end of our node. As per above illustration, following are the important points to be considered. What? Linked list contains a link elements called as first, and each link carries data fields and link field called as next. The data field is used to insert an item or elements, and a link field which stores the address of the next node. Each link is linked with its next linking using its next link. As I said, it consists of link of the next node, and the last link carries link null to mark the end of the list. That means when it is switching from one node to another node to the next node, and so on, at the last node there will be in the link section there will be a null value that marks the end of the list, as in previous have explained. What are the advantages and disadvantages of the linked list? Let us begin one by one. First, I will take what are the advantages of the linked list. What are the advantages? Dynamic data structure, first point. Second point is no memory wastage, and next implementation and insertion and deletion operations. Let us begin discuss one by one. What is dynamic data structure? A linked list is a dynamic arrangement, so it can grow and shrink at runtime by allocating and deallocating memory. So there is no need to give initial size to the linked list. That means the arrays what happens, we should declare the specific size. Here there is no necessary to declare the specific size. As in example I, if you want to insert 5 elements into a stack, you should declare it is an 5 in arrays. But in what linked list there is no necessary to declare it is an 5, because you can increase or decrease during dynamic data. That means during dynamic time, that is during run time. Next, no memory wastage. In the linked list, efficient memory utilization can be achieved since the size of linked list is increased or decreased at runtime. So there is no memory wastage as and there is no need to be pre-allocate the memory. As now I said, if I take 5 elements to be inserted in a stack, there I can insert. If I want to insert sixth element, next automatically during runtime we can allocate a memory. That means increase can be done. For example, you assume that there are 5 elements to be inserted into a stack, but I am not interested to fill all these 5 elements. I will insert only 2 elements. Then remaining 3 elements, they it will occupies the space. That space can be deallocated. That means that space is not used. Therefore, for this reason, we are using telling that no memory wasted is done. Implementation. Linear data structure like stacks, queues often easily implemented using a linked list. Insertion and deletion operation. Insertion and deletion operations are quite easier in the linked list. There is no need to shift elements after the insertion or deletion of an element. Only in the address presentation in the next pointer need to be updated. What happens in linear, that is in arrays, we should do all these process, but in a linked list what happens, for example, now here you see that insertion is an one variable. You assume that update is here, it is little bit far, but these two can be connected by using a link. That means in insertion, if I put this address value into an insertion position, that is in a next or in a link section, then automatically it is connected. So it is very easier. What are the disadvantages of the linked list? Memory usage. More memory is required in the list as compared to the arrays, because in a linked list a pointer is also required to store the address of the next elements, and it requires the extra memory for itself, because we are using pointers in connecting the one node to the another node. Automatically memory usage will be more. Travels. In a linked list, travels more time consuming compared to an array. Travels means moving from one node to the another node. Direct access to an element is not possible in a linked list as in array by index. Example, for accessing a node at position n, one has to travels all the nodes before it. That means it should travel the how much it is there. Reverse traversing. In a single linked list, reverse traveling is not possible. That is the main disadvantage. But in the case of double linked list, it can be possible as it contains a pointers to the previously connected node with each node. For performing this, extra memory is required for the back pointer, hence there is a wastage of memory. That means in a reverse you assume that this is a variable and traversing is another variable. This reverse is contains the address value of the traversing, but in traversing it does not contains the address of the reverse. So the reverse traversing is not possible. Random access. Random access is not possible in a linked list due to the dynamic memory allocation, because the memory is allocated at the run time. How many types of linked list are there? Let us see one. One is a single linked list, double linked list, double-ended linked list, and following are the some basic operations supported by list. One is insertion, adds an element at the beginning of the list. Deletion, deletes an element at the beginning of the list. Display, displays the complete list. Search an element using the keyword. That means in a linked list, if you want to search an element, we will use this one. And delete is nothing but to delete an elements by giving a key. That means which I have required, that elements can be deleted. Insertions. Let us begin. What are the basic operations? Insertions into a linked list can be performed at different positions based on the position of new node being inserted. The insertion is characterized into the following descriptions. What are those? Insertion at begin, that means at the starting. Here you can say that Sn, here you assume that three nodes are there, Sn, operation and description. If these three nodes are there, then insertion can be done at this end, at Sn. This is called as insertion at begin. It involves inserting any element at the front of the list, and we just need to a few link adjustment to make the new node as the head of the list. Insertion at the end of the list, that means here in description part, if I want to insert an element, then we will call it is an insertion at end of the list. It involves insertion at the last of the linked list. The new node can be inserted as only node in the list, or it can be inserted at the last one. Different logics are implemented in each scenario. Next, insertion after specified node. For example, now if I want to insert an element in description, this is also possible. Or if I want to insert an element in between S and operation, this is also possible. That is the meaning of this one, insertion after specified node. It involves insertion after the specified node of the linked list. We need to skip the desired number of nodes in order to reach the node after which the new node will be inserted. Similarly, deletion is also done. The deletion of a node from single list can be performed at different position based on the position of the node beginning deleted. The operation characterized into following is. What are those? Deleting at the beginning, as I told. Here also the elements can be deleted. Deleting at the end of the list, that means here, that is the part of the descriptions. Deleting after specified node, that means if I have inserted the year in between these two, that can be deleted. Then traversing. What is traversing? In traversing, we simply visit each node, the each node of the list at the least once in order to perform some specific operation on it. For example, printing a data of each node presented in the list. If I want to print, you assume that this is are the nodes which are connected. If I want to print, it will travels like this. This is called as a tree traversing. Searching. What is searching? What is searching? Searching is nothing but identifying an required element or item. That means in this, if I want to find out different, this different is in the second serial number. This is called as an searching. In searching, we match each element of the list with the given different elements. If the element is found or any of the location of the element is returned, otherwise null is returned. Now I told different. Now the in this it will go on searching by traversing, and it will find that different is required. If I write my name here, Guru Raj, it will search here there is no my name, that is Guru Raj is not in any of these nodes, and it will return as no elements is identified. Thank you.